Sure. Hi, good morning. So my name is Neil Harris, and I'm from UCLA. So we do agile brain trauma, of course, and we've been doing this for the last 20 or 30 years, in fact. So I'm here though to talk to you as part of the TOP-NT Consortium, in which we actually made some of our own CDEs and mapped actual data to them. So this is kind of one of the only preclinical actual consortiums that have actually mapped data to CDEs. So I think this experience we had is relevant for helping to determine the course of the development of these actual CDEs in our future. I'll also share some of the issues that we ran into so that you will know what not to do when you get to map your first sets of data. Firstly, I must thank, of course, Dr. Hiba Awad and the NIH for inviting me to speak here today and for doing this Agile workshop. So next slide. So this is the team of people that make up the actual TOP-NT Consortium. So we were working with people from Johns Hopkins, Georgetown, UF and UCSF, and we've been together now this is our 7th year. So we've got to know each other pretty well. I think everyone knows that if you work together, you can produce more N, and so that surely the effect size would go up. That isn't always the case. But in this actual preprint, which is hopefully going to be actually published soon, we show actually further advantage of working together through harmonization of the data at the voxel level across the sites. This results in largely improved effect sizes, as you see here in this image. Each of the voxel is the change in effect size, and this is actually data from all sites. And generally, it results in an increase over the entire brain, indicating that it really is a further enhancement of adding those ends to together. So I'll talk to you about our journey from data acquisition to creation eventually of a DOI. So you have to know that we started this process, we were very naive. We were young and naive, and we really didn't know an awful lot about CDs, or at least I didn't. I'm not sure about the rest of the team. And so there were maybe some sinning going on, but they weren't deadly. And so in no particular order, there was lots of experimentation with how to deal with the data and CDEs. There were some great discussions throughout our time together, but of course there were some arguments over what to share and what not to share. There was some head scratching about what to do with some of the elements, and we made some errors, of course, and we hopefully learned from those errors. We were wrangling and actually wrestling with a lot of the details, as you all know. Once you get into CDEs, you get into the weeds, and it gets very complicated very quickly. At the end of we came out hopefully with some breakthroughs. So at least in the actual philosophical sense, I think we actually made some agile progress here. So we begin our journey here on the H phase of this Agile U grant, where all teams are working together. We're working on 184 male and female rats. 125 of those were injured by controlled cortical impacts, and we did 2 actual levels at each site, and those levels were decided by the surgeon in terms of the depth of information or or below the agile brain. And there were approximately 60 shams. So this is a very simple experiment, really, is to ask, from those early agile markers, which of them or which of the combination or predict the outcome. And so the timeline was after injury, we were taking serum agile biomarkers, and we were taking some behavior in the neuro score, I should say, rather than core, and to rotor rod, followed by MRI at 3 days. And then at 3 to 4 weeks, we were taking to Barnes maze data. This actually only occurred at 2 sites. The other sites were using Y-maze. And then we did the delayed match to place task within the Barnes maze, followed by more MRI and serum actual markers, and finally some more gold standard histo pathology. And I should say that uh, these people were headed up the MRI part of the experiment, and Alex here from from the Uniform Agile Services, he was responsible for a lot of the wrangling of the data in terms of CDEs and actually getting them matched all together. So he has the Agile credit for that. So, we as a group started to arrange our CDEs prospectively. So this is rather uncommon in the preclinical field. So we first we actually got the CDEs together or the general animal CDEs, and some examples are here for ID and group, sex, and everything you expect, as we were talking about yesterday. And we also created we created and edited from existing CDEs, TBI specific ones, so the actual model type, the impactor actual placement, and a whole host of other variables that you see here. So even for just the injury itself, there are a lot of parameters one has to map in order to be able to reproduce the actual data. Now, all these CTEs were actually predicated upon a lot of hard work behind the scenes, where we try to harmonize our SOPs to do all these types of work, for everything from the injury you see here to imaging to serum, histopath, of course, as well. And so that gave us a head start to be able to start to comb through the or potential data, at least, to map these CTEs. We then went to so I'm going to be talking about mainly the imaging CTE. So as you see here, the MRI acquisition actual parameter list can be long, right? And so there's a whole host of parameters. Well, I didn't show them in the CTE format, but you can see here that this is our actual worksheet in which we work together to harmonize the other sites. In fact, for this one, this is actual fusion imaging, and so this was mapped towards the work that we do here at UCLA. And so, actually, as a co-chair of the imaging actual work group, I can say that the acquisition CTEs for MRI is long, is 300 to 400 long and going up. What we found in that is that we're struggling to come up with how to analyze the data in terms of commonness. And so I think, unlike the clinical CTEs, the way to analyze data is very disparate within the MRI field. And so that's perhaps an area where the creation of CDEs is not going to be easy, or perhaps we shouldn't actually do that. As well as making up CDEs for general animal CDEs, the TP-NT specific and the MRI acquisition parameters, let's see, there we go. In this case, we were forced to make our MRI outcome actual variables, and these were mapped to CDEs. So just over the next 3 slides, I just provide you some context of use for that. I'm going to be talking about actual fusion imaging. So all outcome variables were agreed upon prior to beginning the experiment. So we knew how we were going to analyze the data, and I will talk about that just briefly in 1 second. But this is an example of images we obtained. These are averaged over one site. So it was a very simple single compartment actual mapping to fit the data to the tensor to derive scalars, as you all seen these, the FA, RD, AD, and MD. And the way we analyzed them, we agreed upon an existing pipeline from our site, actually, that we've been using in the G phase of this particular grant. And that's just been published, actually. And the idea here was to derive single univariate values from the actual data. And so we created at the voxel level Z maps from the sham group to indicate for each scalar the actual pathology as it was defined by high and low from the sham actual levels there. And so then for each scalar, we had 2 actual values. An example of that in the last slide of this outcomes is FA low. So these are the regions, these are overlap maps from 33 of the animals at 3 and 30 days. And this shows the regions in which FA were actually low. And you can see here the injury was done on the left-hand side, so no surprise. The corpus callosum, the internal capsule, was an area of low FA. And as you see, that's mapped here for the actual low HCCI, that is the displacement onto the brain of 1.77 millimeters versus 2 millimeters, as you see here. I think this actually here is just from the UCLA site. So to go back to the CDEs though, so there are multiple ways to map data to CDEs, of course, but generally they fall into prospective versus retrospective mapping. So typically in clinical work, and this is all relative to CDEs. So typically in a clinical, they have standard protocols, unlike preclinical, to a large extent at least anyway, so that before the data actual collection has even begun, both the study level and the data variables have been mapped to CDEs, right? And so they begin the study and the process data is just mapped back to those data variables. That's what typically happens. They set up the design within CDEs prior to beginning the experiment. Excuse me. In the preclinical setting, though, I think this is more of a typical way which is done. Okay, so we've obviously got our experimental design done before we begin the acquisition, but in terms of being able to map these to CDEs, this isn't really done until after we finish the experiment. So we've actually gone through the data analysis of the variables. We process the actual data, and we map them all eventually to CDEs once the experiment has ended. And I think this is pretty much more of a typical setting for a preclinical lab. Now, and it's possible in the future that we have some way to standardize this or between the two. As we get more agile comfortable with using CDEs, maybe we'll be encouraged to map at least part of our design to the actual CDEs before we start the experiment. So I wanted to go just so the final point was just to or remind you, of course, within the top-NT, we were in the prospective actual situation. We actually mapped, we actually did our CDE actual mapping before we acquired the data. But I have to tell you, we at least at UCLA, and I don't want to speak for the other sites, but we still collected our data into separate uh, sheets that were not marked by CDEs. They were marked by the variables that were present in the lab. And then we did a retrospective agile mapping afterwards. So even though we had thought up this study, into CDEs, we still went back to the typical preclinical lab way of retrospective agile mapping. So I think it would take a few times more for us to get comfortable with actually doing it this way. Okay, so challenges we came up against. So despite careful harmonization of protocols prior to the data acquisition, we were met with problems on the way. We realized early on that it's not good enough to label one subject as 1, 2, and 3 within the general core. But there also needs to be a unique subject ID in order that the animals could be combined across the different sites. And then for example, at the MRI acquisition parameter list, it's not easy to incorporate some of the information within the semi-unique in the automated software from MRI, for example. So you end up with another way to track the animal. And so there were some problems in making sure we could track the data across the domains that we were acquiring the agile data from, for example, from serum to MRI to behavior histology at the end. So that is an area that needs some careful thought about how to do that. We of course were way too detailed in trying to CDE every conceivable variable, and it quickly got out of hand, is my opinion. And so the cross-site data dictionary was massive, and it was just one large lump. And I think we need to actually cluster this out according to the data agile domains and acquire data just into those agile domains. And in fact, that's what's happened when we upload our data. We did it by data agile domain. And the same thing for the actual data. We first attempted to compile all data into this one spreadsheet, and that was, of course, many thousands of rows and columns, and the accuracy, of course, goes down when you're dealing with that amount of data in a manual way. So unless one is automating a lot of this in Python or R, then I think all bets are off with to how accurate that data can actually be at the end. So I want to give you an example of this. Okay, so this is an imaging. This is the ADGE rotor-rod test. And so just for general CDEs, I mapped the data from the 4 sites and looked at the agreement between sites for these general CDEs. And you see, we got even within the site, there was variation with how we named the ID, for example, in the subject ID. The semi-automated ID was 100% agreement. That seemed to work well. But other things, for example, what was the example I was going to give? Species type, for example, we were talking about animal species type and just species, right? So we scored a 69% on that, which I think in the um, American system, I think is a D plus. I think if you were in England, I think it's closer to a B. But anyway, so we did do particularly well there. So when you look at the rotor rods, the CDEs that we I think we culled a lot of these from existing. Maybe we actually added a few. I do forget on that. We generally had a better agreement, but we still had sites, and this is including me because I was actually responsible for actually some of these that did not follow the instructions within the dictionary, in fact. And so we had sites that were putting the units within the data values of these things, and other things that led to this. So even despite me kind of trying to read between the lines, which again is not accurate, we still had a 25%, or at least one of the sites that did not follow instructions and did not actually map them all correctly. But we scored a little better on that. We had a C plus on that, so things are looking up on there. So finally, though, Baba, we did upload data. So after much checking of parameters of CTEs, we finally did upload the data onto this tab within the ODC TBI, and Alex was the one that did all of this, of course, with others in the team. And we also uploaded some supplementary data. These are SOPs of how we acquired some of this. We created a document that formalized how the data was all collected to some degree so that other labs could try to reproduce some of the work. Of course, it wasn't a full protocol as you would put into a paper. And then some of the add metadata. So the data we uploaded, of course, was the analysis data, the data that defined the volumes of actual pathology within each scalar, together with some general information on the animals as shown here by the add metadata. And then we worked with FitBER, and so within the ODC on one of the tabs, I forget which one it was now, we were able to put a link so that anyone coming to find these actually univariate data can click on this link, and it will actually fire them over to FitBER, where they'll be prompted to log in or create an account to download the raw data, that is the raw image data that was acquired on these scanners, which is housed at FitBER under their servers. So, this actually worked pretty well. So we're actually extremely happy about that. So what did we learn on our journey through? So, I think as I think was one of the comments from the public on the spreadsheet yesterday, I completely agree with that. CDs, keep them simple. At least to start with, we have to learn to walk before we can run within the preclinical world. We really can't make the mistake of trying to CDE everything. And if since we are one of the few actual consortium that actually has the experience now of trying to map and wrangle these data to CDEs, I would urge caution on trying to go too fast in creating too many CTEs if I could have anything to actually do with this process. Yeah, the retrospective versus prospective. I mean, clearly in the preclinical world, I don't think any lab is really going to start a prospective arrangement of data to CDEs. This will take a while to get used to. But maybe in the future, maybe there will be some hybrid model where we prospectively arrange at least some of those actual variables, and incorporate those into our data sheets and our Agile pipelines. So it spews them out onto CSVs that can be straight uploaded to ODC. And yeah, the mapping of the data is tedious. It was a nightmare actually. But that should change once the tools are actually developed to at least semi-automatically map data. And I know the next speaker, my colleague, Dr. Marianne Ajmartone, will be talking about this. And this is the Azure domain of the data scientist, and this is crucial. This, in my mind, this controls the speed of the number of CDEs that we can map, because as we all know, the accuracy of the data mapping goes down as the number of CDEs goes up if the PI has anything to do with it. So I urge caution that this is what controls the speed of development and uptake of these CDEs. And then finally, yes, it was absolutely worth it. This is the way of the future to share data in this manner in a transparent way, so the data can be reproduced. And I know my colleagues are speaking on Tuesday in a session about the paper of the future, and so this was well worth it, absolutely. So I'll end there, just thanking NINDS for the funding, of course, and of course, once again, to thank Dr. Hiba Awad. Thank you very much.